Hello, ladies and gentlemen, my physical science class. Mr. Hescock's back. Picking up, we just talked about all those different gentlemen who worked on the theory of the atom and who started the theory. That would be Democritus, 2,000 years ago plus. Atoms in Earth. Types of atoms in the Earth crust are living things. Mostly you have carbon, hydrogen, and oxygen as far as living things go. Hydrogen is about 90% of the universe, but not as common on Earth. The Earth is much more other things. Stars are made out of hydrogen. That's why there's so many billions of stars. Most hydrogen on Earth is combined with oxygen to form water. The big ones then on the Earth's crust: iron, aluminum, silicon, oxygen. When it comes to living things, carbon, oxygen, hydrogen, and nitrogen, and some sulfur. Sometimes you have some magnesium, some chlorine in there. Elements get their name from the Greek or Latin from the person who discovers them, or you can name the element after a person, like there's Rutherfordium, who was named after Ernest Rutherford from the other day's lesson. There's an Einsteinium, who's named after Einstein. Iron, such as, is the abbreviation Fe, which actually from Latin was ferrum. Gold was Au, which is aurum, and these other ones are in there. Silver is Ag, lead is Pb. And it says the first letter of the chemical symbol is always capitalized, the second letter is always lowercase. In this scenario, it talks about CO, capital C, capital O, and CO. This one is carbon, and then that is oxygen. And then this C with a little o is actually cobalt. Carbon monoxide is very poisonous. Cobalt is used in a lot of different metal alloys. Is silicon the same in Spanish? C or Si, because that's silicon. So I have a lot of these bad science jokes. You just have to put up with them. Cats are composed of iron, lithium, and neon. Feline, Fe for iron, Li for lithium, and Ne for neon. Feline. This is a Google picture of the periodic table. I will have printed ones of these for you. You guys can use them and keep them for the next few chapters. I highly recommend that you can just write on your paper. That way, as we cover some information, we can write on them and keep that there for your test. Speaking of my bad jokes, how often do I make jokes about chemistry? Periodically. Get it? Periodic table, periodically. Each element of different types of atoms is different. This was from John Dalton, but he also believed that they couldn't be divided, so that was wrong. Let's take a look at the structure of an atom. There are three main parts to an atom: protons, neutrons, and electrons. Right here is my proton. I often on the board will write these as P with a positive. Neutrons are N with a 0, meaning they have no charge. You'll often see me write electrons as E negative, electron, and then they're negative. Now, a lot of people want to say neutrons negative because of the N's, but it's not correct. Neutrons are neutral. A neutron wanted to pay for his food. The waiter says, "For you, no charge." Get it? No charge. What do you do with a sick chemist? If you can't helium and you can't curium, then you might as well barium. Ha ha ha. Love that one. Atomic structure. So the atoms are super, super small, 10 to the minus 10 meters. That's actually into the nanometers and smaller. Most of the atom is empty space, over 10,000 times of the part of the atom compared to the nucleus to the electron cloud. So one guy once told me that if you place a baseball on the pitcher's mound of your favorite pro baseball stadium, the baseball is the nucleus. The rest of the stadium is actually the electron cloud and empty space. Electrons, as far as we know, are the fastest moving objects. They are moving at almost the speed of light. So it's like they're in two places at once because they're moving so fast. We can only predict where they are, but we can tell that they're there because they have these negative effects to them, negatives and positives. In fact, the positive nucleus, the positive charge of that nucleus, actually keeps those negative electrons spinning around it. Every atom has a square or a tile on the periodic table. There are some things that we have to talk about as far as the tiles on the periodic table. The atomic number is right here. Hydrogen is 1, helium is 2. The atomic number is always the number of protons. Then we have the chemical symbol here. And the atomic mass or atomic weight right here. The atomic mass is the average of all the isotopes. So they take, to get the atomic mass, this is neutrons plus protons averaged out. The atomic mass of a number is equal to the total number of protons and neutrons in the nucleus. Not all atoms have the same number of neutrons, and we call those isotopes. So if it has the same number of protons but a different number of neutrons, it's an isotope. Some of the more common ones for helium, there's like 3 different isotopes of hydrogen. There's isotopes of helium. There's isotopes of carbon. A particular isotope is given the name because you use the chemical and then they use the mass number. So like carbon 14. Carbon usually has a mass of 12. There is a heavy carbon that's radioactive called carbon 14. It has 2 extra neutrons in it. Let's practice a couple of these together, and we'll do some more in class. Fluorine. Fluorine has an atomic number of 9, so that means it has 9 protons. Fluorine has an atomic mass of 19. Well, if you take 19 minus 9, there have to be 10 neutrons. Okay, let's jump to gallium. Gallium has an atomic number of 31, so the atomic number is always the number of protons, so we have 31 protons. It has an atomic mass of 70. So you take 70 minus 31 and you get 39 neutrons. All right, ladies and gentlemen, I'm going to cut those. You guys will be doing these practice problems yourself anyhow. Atoms can form ions. When they form an ion, it is because an electron is transferred from one atom to the other, making this one positive because it has lost a negative electron when you take 2 negatives. So if you have 0, minus minus 1. Because an electron is minus 1, its charge will be positive 1. At the same time, this chlorine right here, the chlorine is going to gain 1. So it was at a charge of 0. I'm going to add a negative 1. The charge of my chlorine is now negative 1. What happens then in this case, they attract. Hey baby, I got my eye on you. Forming a positive ion. To form a positive ion, you must lose an electron. Depending on the row of the periodic table, everything in group 1 loses 1 electron, becomes a positive 1 charge. Everything in group 2 becomes a positive 2 charge. Group 3 through 12 and 13, well, 13 becomes a positive 3 charge, but everything in 3 to 12 is 1, 2, or 3 because those are called transitions. To form a negative ion, you must gain electrons, meaning you have more negatives than you do positives. For every electron that you gain, you become 1 negative, like you're adding a negative charge. So let's do some charges here, and then we'll probably be about done for the day. Aluminum is in group 13. It has 3 valence electrons. It loses all 3. Well, when you take away 3 negatives, you become positive 3. Magnesium is in group 2. It has 2 valence electrons. It'll become positive 2. Same with calcium, positive 2. Bromine has 7 valence electrons. It would like to get to 8, so it gains 1. So when I gain a negative 1, my overall charge, negative 1. And oftentimes they write it backwards. Chlorine gains 1, so it becomes negative 1. Nitrogen is very interesting. Nitrogen only has 5 valence electrons. So it would rather get to 8, so it needs to gain 3. If I gain 3 negatives, my charge is now negative 3. All right, ladies and gentlemen, we've covered quite a bit of material, and we'll practice and practice and practice. Just like sports, the more you practice with this information, the better you'll get at it. We'll go through chemistry here in chapter 5, 6, 7, and 8 to get you prepared for high school chemistry and that good old PSSA test. If you have any questions, look me up. This will conclude 5, section 1, and you get your review. Make sure you get those review questions for 5.1 done. Until next time, be good, be safe. I'm Mr. Hescox. I'm signing out. Bye.